Despite the widespread belief that the main producers of robotics are Asian countries, particularly Japan and China, Iran has introduced its latest humanoid robot to the world, and the US is on high alert. Mechanical engineers at the Iranian University of Tehran have been working on Serena robots since 2010. Their latest model is called Serena 4. This adult-sized humanoid reportedly has face and object detection, speech recognition, and generation, walks at a speed of 0.7 kilometers per hour, and can grip various shapes and objects. It has 43 degrees of freedom. Engineers use Serena to research bipedal locomotion and AI, and to attract students to engineering careers. The device was developed at the Center of Advanced Systems and Technologies at the University of Tehran. It can perform unique operations that make it more human-like. The robot, fully designed by Iranian developers, can write its name, balance on one leg, grasp a water bottle, drill a wall, and even take selfies. Professor Yousefi, a professor of mechanical engineering leading the research group, believes improving robot interaction with the environment is crucial for future AI development. Although Serena cannot perform parkour like Boston Dynamics Atlas, it balances better, interacts with more objects, and can perform most tasks that an average person can do. To make his robots more widely known, Professor Yousefi has sought to take them to international conferences and trade shows, and his group has published papers on humanoid robot design, bipedal locomotion, and other topics. He has said that his group wants to make Serena very competitive and may be taking part in an international challenge as well as finding real applications and users. Figure, an AI robotics company, unveils its second-generation humanoid, Figure 02, on August 6, 2024, introducing the highest-performing humanoid robot to the market. Figure's robot combines human-like dexterity with advanced AI to perform a wide range of tasks across commercial applications and, in the near future, in homes. Figure's top-notch engineering and design teams completed a full hardware and software redesign to achieve Figure 02. Technical advancements were made in critical areas, including AI, computer vision, batteries, electronics, sensors, and actuators. Figure 02 can engage in speech-to-speech conversations with humans using onboard mics and speakers connected to custom AI models, trained in partnership with OpenAI. The humanoid has onboard vision language model that enables fast, common-sense visual reasoning from robot cameras. A 2.25 kilowatt-hours custom battery pack in the robot's torso delivers 50% more energy, maximizing runtime. Integrated cabling for power and compute communication allows for concealed wires, higher reliability, and tighter packaging. Figure 02 perceives and understands the physical world through its AI-driven vision system powered by 6 onboard RGB cameras. Figure 02 has 3 times the computation and AI inference capacity compared to the previous generation, enabling fully autonomous real-world AI tasks. Figure 02 recently tested these new capabilities at BMW manufacturing, where it performed AI data collection and use case training. In addition to its partnership with BMW manufacturing, Figure has announced several significant achievements since being founded in 2022, including a recent Series B raise of $675 million and a collaboration agreement with OpenAI. Figure's goal is to create robots that will not only enhance productivity and efficiency, but also improve the quality of life for humans. The advanced capabilities of Figure 02 bring the company one step closer to achieving that vision. Norwegian robotics company 1X has announced its humanoid robot, Eve, which is now commercially available. This marks a significant advancement in domestic robotics and the integration of AI into everyday life. Eve is designed to be more than just a simple machine. It is a versatile household assistant capable of performing a wide range of tasks. While the AI-powered robot has already been deployed in various industrial settings, demonstrating its efficiency and reliability, its introduction into the home environment is groundbreaking. Eve can handle chores such as cooking, cleaning, and even home security, making it an invaluable addition to any household. Its capabilities extend beyond basic tasks, as it can adapt to different household needs and routines, ensuring a seamless and efficient operation. Eve uses a modified version of ChatGPT to understand and respond to commands, and 1X said the AI capabilities allow Eve to be a learning and creating robot. For instance, Eve can generate recipes by scanning a user's shelves and identifying ingredients and replicating a user's movements to effectively complete tasks. The wheeled robot stands at 6 feet 2 inches, weighs 192 pounds, and is capable of traveling 9 miles per hour. It can also carry up to 33 pounds of goods and comes with gripper hands, so it can hold various objects to assist with cleaning and cooking chores. LimX Dynamics introduced a new humanoid robot called CL1. The Shenzhen, China-based company claims that CL1 can perform various tasks by closing the loop between real-time perception, gate planning, locomotion control, and hardware and data streams. During testing, CL1 used perception control to adjust its motion proactively. This allowed the robot to take smooth steps onto a curb, ascend stairs dynamically and fluidly, and walk down a 15-degree slope. The company tested CL1 indoors and outdoors, from afternoon to dusk, to evaluate its performance in different environmental conditions. LimX Dynamics expects its humanoid robots to be deployed in B2B and B2C applications. They plan to focus on hazardous scenarios, high-end customer service, automotive manufacturing, and in-home services. The company's environmental perception technology is a key part of the evolution of its humanoid robots. CL1 uses advanced algorithms to achieve full-loop integration of perception, controls, and hardware, according to LimX. This allows the robot to break free from the limitations of blind locomotion and achieve real-time interactive motion with its environment. The robot uses self-developed actuators, which the company claims provide exceptional impact resistance and precise, rapid torque control. All of its robots, from wheeled quadrupeds to humanoids, are based on a core set of algorithms. The Kargu 2 is a quadcopter drone built by the Turkish company STM. It uses machine learning algorithms embedded on the platform, enabling it to operate autonomously, as well as manually. Unlike the Bayraktar TB2, the Kargu 2 is designed as an anti-personnel weapon, capable of selecting and engaging human targets based on machine learning object classification. Although various ammunition options are available, the Kargu 2 detonates an explosive charge close to the target, minimizing collateral damage. Due to these characteristics, humanitarian concerns should focus on the drone's ability to distinguish legitimate military targets from protected civilians and direct its attacks accordingly. The technical difficulties of proportionality assessments when civilian collateral damage is expected are irrelevant unless the Kargu 2 is deployed in heavily populated civilian areas. Weapons that cannot make this distinction or limit their attack effects are already prohibited under customary international law. Commanders and operators must do everything feasible to verify that targets are legitimate military objectives and cancel or suspend an attack if it becomes apparent that the target is not a military objective. The drone's machine learning-based object classification using real-time image processing may help meet the distinction requirement. This is especially true if the system is trained to recognize features common among legitimate military targets, such as uniforms and other visual indicators of military affiliation. Thanks for watching, and make sure to hit the like button, subscribe, and put notifications on to stay updated on everything related to AI and robotics.